Hey guys, today I'll be going over learning target 8, which relates to the meaning of a derivative. So here we're given a graph of f of x. We need to find or estimate some values, mainly derivatives. So let's look at this first one. We have f prime of -3, where x is equal to -3. So that occurs right here, and we need to find the derivative. And the derivative is basically just the instantaneous slope, but we have a straight line, so the derivative is just going to be equal to the slope of the line there, which is -1. Next, we have f prime of -1, which is right here. This is also a straight line, so that slope there, rise over run, will be 2. The third one is a little wonky, f prime of 0. F prime of 0 occurs right here, and I'm looking at the slope, and here I have that same slope of 2. But then here I have the slope of 0, so it's not going to be an average of the two, it's just going to be dne. We can't really tell you what it is. It's not really differentiable at that point, as one might say. And that is because that is a corner. It's where two different slopes meet. Finally, f prime of 1, that's right here. I'm looking at a horizontal line, so our slope is going to be 0, or our derivative is going to be 0. And then it asks us which x values of f prime of x are greater than 0. So looking for positive derivative or like positive slope. So let's start all in the left here. This is negative slope. I get to here. Oh, now I have positive slope. And then here I have 0 slope. And in this part right here, this is a curve. This isn't a completely straight line, but it's decreasing, which means the derivative is less than 0. So using our interval notation, we are increasing from x equals -2 to x equals 0, and decreasing or having 0 slope everywhere else. Now we need to find f prime of x using the limit definition. So this is a pretty fundamental thing in the course. This equation is how they originally found derivatives of functions. And while it can be a bit of a pain sometimes, I'll be honest, it's very fundamental, as I said. It's pretty interesting how this came to be. Basically, it kind of looks like a random equation, f of x plus h minus f of x over h. Basically, that's just saying that if you find if you're at a point on a function or on a graph and you just increase that by just the tiniest bit h, which is almost 0, and then you subtract it by just the original function value and divide it by said h, you'll have a slope. And this works when we use a limit as h approaches 0. It's pretty much just like a technical thing because you can't really have an increase of 0, like you would just get 0 in the numerator, but h is just infinitesimally small. Anyways, that's enough yapping. Let's go through the problem. We have limit as h approaches 0, and I'm kind of lazy, so I'm just going to copy this so I don't have to write it every time. I'm going to be writing a lot. And it is important to keep your limit notation as you go through a problem like this. It can be a pain for sure, but mathematically it's the best way to do it. So we have that f of x plus h. This basically just means that we're plugging in x plus h whenever we see an x in the function f of x. So keeping parentheses, which are very important, negative x plus h squared plus 4. And we're going to subtract our f of x, which also using parentheses, with negative x squared plus 4. Reviewing these checkpoints, I see quite a number of mistakes, like subtracting a function that is more than one term. Sometimes what people will do is they'll subtract that first term and then just add that second one. And that's not going to be quite right since this -1 is distributed to both. But anyways, a little bit of a side tangent there. Just something to be aware of. I always like using parentheses when I'm substituting in. Sometimes it can be redundant, but it doesn't hurt. So moving on, we have I copied it for no reason, I guess. I'll just write it. We have the limit as h approaches 0. And we're going to simplify this down, we have to expand our term that's being squared. So keeping that negative 1 out, we'll have x squared plus 2xh plus h squared plus 4. And then distributing that negative 1 in the subtraction, as I mentioned, we will have plus x squared minus 4. This is all over h. All right, let us distribute that negative 1 in front of the polynomial. We have negative x squared minus 2x each minus h squared plus 4 plus x squared minus 4 all over h. Now look at this and I see a few terms that we could cancel out, that like subtract out. I have a negative x squared and a positive x squared, boom, 4 and negative 4. And that's good for now. So we will write limit as h approaches 0 of negative 2xh minus h squared over 0, sorry, over h. And what I'm going to do from here is I'll factor out an h in the numerator. So we'll have h negative 2x minus h all over h. And what you can see here is that this h and this h will divide themselves out. So if the limit as h approaches 0 of negative 2x plus h, and we see one h left. This looks pretty darn simplified. So let's just plug in 0 for h. We will get negative 2x. That is our derivative of the function there. Negative x squared plus 4, its derivative is negative 2x. Using the limit definition is definitely a lot of work. It's a pain, but it's good to understand what's going on, and it'll make learning all of the different strategies for solving derivatives really easily. It'll make it feel very good and very efficient. I promise you that. So if you have any more questions on this topic, as always, you can stop by office hours and ask any questions you may have.